Uh-huh, uh-huh, uh-huh. Uh-huh.
Okay, today I'm going to be teaching you guys about alternating series test error. Now, what this is and why it's important, you need to first understand what an alternating series is. So, an alternating series is any infinite series where each term in it is the opposite sign to the term before it, which means it'll look something like this. It'll be a series, obviously, that goes to infinity because it is an infinite series. It'll always be in the form of -1 to some n, in this case it'll be n plus 1, and it'll always be multiplied by a base function. So for this example, I'll use 1 over n, just to be simple. Now when you write this out, you will begin with a number, which in this case when you plug in n equals 1, it'll be positive and it'll just be 1. And the next term will be a smaller number, so it'll be less than 1, but it will be opposite in sign. So it will always be negative. In this case, it'll always be negative, and it'll always be less than 1. So if you actually plug in n equals 2, you get -1 times 1 over 2. So it'll be -1/2. Then we keep going, and it'll be the opposite sign again, plus 1/3, -1/4, plus 1/5, and it'll keep going on until n equals infinity. Now, the reason it does this is a converging alternating series, which means that as it goes to infinity, this will eventually come to 0. And because of that, the alternating series will also eventually come to 0, which can be shown as follows. So, as n goes to infinity, 1 over n, which is the base function, equals 0. Now the reason why this is important is if we actually graphed some of these terms out, like so, there's 1, there's -1. The first term will be 1, so I'll put that there. Next term will be -1/2, then 1/3, 1/4, and then it'll keep going until it goes to 0, and as n goes to infinity. Because it decreases, what that means is if we add the terms, I'll do the sum of the terms with stars. If we add the terms, so 1 -1/2 plus 1/3 -1/4 plus 1/5, this will also converge to a single point. Now it only does this if it is a decreasing function, which 1 over n is. Now, what the alternating series test error determines is if you have a partial summation, so you have, instead of something like this, instead of going to infinity, instead it goes to, say, m. What it states is the maximum error that you can have in this situation, so this would be the summation of all the terms minus what the value is up to, what the summation is up to that value of the same function, is less than or equal to the value of the m plus 1th term. So for example, if we take what we had before, if we wanted to know how close this piece was to what it would be if we added all the terms up to infinity, all we would need to do is look at the next term in the sequence. So this is within this of this. So this is within 0.2 of all the terms added together. Now, for an example, using the same summation, how many terms do you need to add the following series for the sum to be accurate to 4 decimal places? So how many terms do we need to add until this is accurate to the entire amount to 4 decimal places? Which is another way of saying is, how many terms do we need to add until the m plus 1th term is less than or equal 10 to the minus 4. Okay, so in this particular example, this is a fairly easy one because of the function simplicity. 1 over n is a fairly simple function. So, to find what this is, we start plugging in values, and because it's so simple, we can immediately notice that it's when 1 over m is less than or equal to 10 to the minus 4. So we can say immediately that m is less than or equal to 10 to the 4th. Now what this tells us is that we would require, in order to get an accuracy of 4 decimal places, we would need to add the first 10,000 terms. Now this is a fairly high number, and it's not going to be like this for all examples. So here's the next one. It's a little bit more complicated. What is the maximum error for the first 3 terms of this? So what we're trying to find out is how close, if we add the first 3 terms of this, how close are we to all the terms added together in the infinite series. So plug it into a calculator. You start with n equals 1. You should get 1/2. Second term will be minus 1/16 plus 1 over 72. So these are the first 3 terms. Now the error will be the absolute value, and it'll be negative, but it'll be the absolute value of 1 over 256. So what that means is the error for the first 3 terms of this infinite series is less than or equal to 1 over 256. And there you have it. That is the alternating series test error.
Da da da.